Hey everybody, in my last video I showed you how to compute Fibonacci numbers using recursion, and the twist that I put on it is that I define a recursive function for Fibonacci's where I enumerate what the base cases are. I show you how to split the problem into two smaller problems, and then I show you how to combine the results from solving the two smaller problems. And then I use this function called recurse.spicy to basically implement the recursion, and it actually does it in a non-recursive way. And I will let you look at the prior video for the details on that. But in this video, I'm just going to extend the concept to taking the 2000th power of the number 3. And all I'm doing here is that I'm saying that the base cases, in order to recursively compute a power, instead of normally when you compute a power like the most naive way, you're taking 3 to the 2000th power, or you just 3 times 3 times 3 times 3 times 3, 2000 times. I won't say it all 2000 times. But in order to do it recursively, you can effectively say that 3 to the 2000th is really 3 to the 1000th squared. 3 to the 1000th squared is really 3 to the 500th squared. 3 to the 500 squared is 3 to the 250 squared. 3 to the 250 squared is 3 to the 125 squared. 3 to the 125 squared gets a little trickier because that's 3 times 3 to the 62 times 3 to the 62 times 3. But certainly for even numbers, the divide and conquer strategy is pretty obvious. So what we do here, for our base cases, those are pretty simple. Any number to the 0th power is 1, and any base taken to its first power is just that number itself, the base of your exponentiation. And then the split thing here is literally a divide and conquer. We're gonna return two things. We're gonna return the number divided in half, and then the number modulo 2, which that will always, of course, either evaluate to 0 or 1. And then in the combined step, this a is basically the half of the number, so we're going to take a times a and then times b, where b is basically the result of evaluating our function at either n equals 0 or n equals 1, which, by the way, will always just come from the base cases. So I'm going to run it now. You can see that 3 to the 2000th is this enormous number. But in order to test that my recursive power function works as intended, again here, all I do is assert that that number is indeed what you would get just by using Python's native exponentiation of numbers. So obviously this is not like super interesting for the concrete case, because you can always just exponentiate numbers using Python's native exponentiation. But now we have a function that allows us to recursively take a power on any set of values that support the notion of multiplication. So in my next video, I think I'm going to do this with like square matrices, and I'm going to exponentiate matrices in a way that allows us to compute Fibonacci numbers in a more efficient way than probably most people normally do it, and in a way that should give us exact integer results. So anyway, I think I'll end it there. All right, thank you. Thanks for listening.